Hi there, my name is Odin. I am the founder, owner and CEO of iStill. And in this video I want to tell you more about the design of the iStills, what we bring to the market, what technologies we have to help you out as a craft distiller. I want to talk about our production strategy and how it facilitates us building units at an affordable price level. And last but not least, I want to dive into quality. How do we build things? How do we engineer things? What are our goals? Let's start with product quality. We are currently the only manufacturer of distillation equipment that offers you a 10-year warranty. And there's a reason for that. We build things better, stronger than anybody else out there. And that's important to us because we've got over 500 stills in operation all over the world. We don't use very expensive sales forces and support offices because we feel that if we build correctly at a very high level of quality, you'll have units that will serve you for 20, 30 years to come. So if I talk about the quality of the iStill and how it's built, I got inspired by the Dell computer company. You may remember them from the 19s and the early 2000s. They were the first computer company that actually didn't sell through shops, but sold to customers directly. Of course, they needed to build their computers much stronger and sturdier than anybody else because the customer couldn't go back to a shop to have problems fixed. Dell computers just worked and worked for years and years. And that's what we do. That's where we drew inspiration from when we designed a new generation of iStills. They're going to serve you for 20, 30 years without any trouble. And I'll give you a little example of over-engineering and what we feel quality should look like. This is a three-way solenoid system. What actually happens is that as the distillate comes out of the still, out of the column, based on the computer settings, cuts are made for heads, hearts and tails. Now you can buy very cheap solenoids in China for $13, or you can have them made in Japan or Germany for $73. There is a price difference, especially with all the machining that we put into it. And just to give you an idea how important and well made this is, I put up a scale here. And I want you to guess how much this will weigh. You'll be surprised. That's almost 3 kilos. 3 kilos of iStill engineering. One of the parts, just one of the parts of our systems, engineered to the extent you could actually kill somebody with it and they'll still work. Now and for the coming 20 or 30 years. Having spoken to you a little bit about the quality of the iStills and the 10-year warranty that they come with, I'd like to dive in a little bit on our production strategy and philosophy. We don't build one still, we don't do one-offs. Our philosophy in terms of production is that we do batch production. We're the only one in the world who can do that because we have 500 stills out there already. We don't build one iStill 2000 and maybe for you an iStill 5000. We probably build 2 or 3 5000s in one go, 4 or 5 2000s in one go, and up to 8 iStills 500 in one go. The reason we batch produce is, first of all, the quality of everything we build is meticulous, everything is the same. The other thing that we achieve by batch production is very low costs of building. If you have to build one unit at a time, it takes a lot of time, you can buy a limited amount of materials and you have to specialize on anything you do. If you build 8 or 9 iStill 500s in one go, you can specialize on the boilers, you can specialize on the lag, somebody else can dive into the columns. And we can buy in material for around 60% of the costs. So if you wonder how is it possible that we can put an iStill 5000 out there on the market for around $65,000, $70,000, the reason we can do that is simply because we built many of them. So we told you about the quality, we told you about our production philosophy. Let's dive in why they look the way they do. I mean, we get a lot of questions about them. Why aren't they made out of copper? Why stainless steel? Why are the boilers square instead of round? Everybody chooses round. Why did we go square? One of the first things I want you to know is that copper plays an important role in distilling and in a distilling machine. It takes care of a bad ferment. So if you've got a lot of sulfurs created during your fermentation, you need copper as a catalyst to get rid of it. But the whole copper column will rust on you, oxidize on you. It will be eaten away in around 15 years. It will create copper particle contamination into your drinks. So that's why I don't like copper columns. What I do instead is build stainless steel columns with copper catalyst. Dedicated place in the column, you can flip those catalysts out or put them in. Unique copper waffles with a surface area of a complete column without the hassle, without the price, without copper contaminating the drinks you want to sell to your customers. So that's one of the first innovations and why the ice stills are made out of stainless steel. We have the copper functionality, we put it in a catalyst for your convenience. So why are the boilers square, Odin? I'll tell you, even my own engineers weren't on board on that right away. First, let's take one step backwards. I want you to know that I'm a big fan, and so should you, of directly fired boilers. The reason is very simple. Directly fired boiler versus an indirect fired boiler saves you 50% of the material. So it's cheaper to build, easier to maintain, but also if you fire it directly, you turn up the power, you get more speed. You turn down this power, distillation process goes down. If you indirectly heat with an oil bath, not only is it much more expensive, it's also less efficient. And if you turn up the power or turn it down, nothing really much happens because there's a shitload of oil, shitload of stainless steel, heck, maybe even copper to warm up. Second reason why I really like direct fired boilers has to do with the fact that a direct fire boiler creates the Maillard reaction. What that is, it's a browning reaction, a taste cascade. You can see it happen if you bake instead of boil potatoes or if you fry a steak instead of putting it in the oven. Slight temperature differences create it and add up to 20% more taste to your distillate. 20% extra that an indirect boiler doesn't give you. Now there's one more thing that helps create taste during distillation, and that is organics. If you've got grain present during the distillation process, not just the beer but also the grains, if you've got pomace ready to be distilled and not just the wine, again you will create more taste, more Maillard reaction because some residual organics as well as sugars are available to trigger this chemical event that we want to have. Hey, but how can we do direct fire together with organics? We may scorch the heating element, right? The only reason why people buy indirectly fired stills is to prevent scorching. And then again, all of a sudden they lose out on Maillard and they get less tasty products. I don't think we should go there. Now, this was the design challenge for the next generation of ice stills. Direct fire still that can actually deal with and handle grains and pomace without any issues. The best of both worlds instead of a compromised product. If we look at a boiler, for sure, direct or indirect, we need to agitate it, right? To keep those grains floating and moving around. The problem with an agitator, in a round boiler that is that you create a vortex. So what's happening, if you start to agitate traditionally, you create a vortex that actually competes with the columns over gases, but you also create a mirror image of your grain or pomace, mirroring the actual vortex. So you don't get perfect particle distribution, you get very imperfect particle distribution. This is what happens in a round boiler, and the reason it happens in a round boiler is because as you agitate, the mass you are agitating starts to move with the agitator. All of a sudden you lose 70 to 80% of your mixing capacity. What I did with these square boilers, if you look from above, you have to imagine that these corners aren't like 90-degree angles, they're flush square, is that if we agitate so fast that the beginning of a vortex or a circular movement is starting, it will trigger a counter movement in the corners, stabilizing the vortex. In plain Dutch or English, a vortex is never formed. We do add all the mixing power because we don't have an agitated mash, the mash stands still. So all the power we put in goes to particle distribution. If we look at the side of a square ice still boiler, we see all the particles evenly distributed. So why do we choose square flush boilers? Why do we have such an expensive and innovative agitator design? Because we want you to mix perfectly to reap the benefits of direct fired stills together with the taste explosion of Maillard. So, we talked about the square flush boiler, and you now understand why you need one, right? Let's look at the column. It's just as interesting. Let's say we've got the square boiler here, and we build a column on top of that. What most people do, most of our competitors do, is that they put something on top of their column which is called a deflagmator. It's a heat exchanger. Water in, water out, and some of the gases we actually harvest and reap as product. Some of the gases that rise up from the boiler are cooled down, redistilled on plates to become stronger, more pure, and part of the gases are actually harvested as product. Vodka, fruit brandy, people even try to make whiskey on rum on them. Not always that good, but then again, you can try it. Why I don't like this system is because this cooler and the efficiency and the management of your column is dependent on water temperature, ambient temperature, water pressure, as well as air pressure. So there's 4 variables that make it very difficult to do the same run over and over again. So what I did, I skipped the whole outlet. I beefed up this one and I made a collection system just underneath it. Product comes out here. All the gases are turned into liquids. And from the liquids we select the product we want. If we don't want it, we have a robot that closes and opens. So more of the product is redistilled or less of the product is redistilled. More redistilling for a higher ABV and more purity. Less redistilling for more taste, like whiskey and rum. Or gin, indeed. The advantage of this system over the old deflagmator system is that the only thing we now have to deal with is air pressure. Water pressure doesn't matter as long as we cool everything down. Water temperature doesn't matter. Ambient temperature, who cares? Air pressure is the only variable we still need to manage. Much more control, better runs, better separation. It's much easier to do run after run after run, making the same product over and over again. How do we influence, how do we manage air pressure? Well, we don't, it's a given. But we've got a computer, right? And the computer looks into air pressure, looks into what you want to make, and actually tells the robot to open or close, and tells the solenoid valves you saw at the beginning of the video where to cut for heads, hearts, and tails. Corrected for air pressure. That's a second really big innovation. And if you want to understand what it means you just gain 50% on your running costs and 100% on the quality of your product. So we looked at the boiler and we looked at our column management system. Now let's dive into the column. You see that over here I designed or drew a few plates, and that's how usually stills are made, or traditionally how they are made. Since 1860, 1870, perforated plates, especially bubble caps. I don't like bubble caps because in this case we've got 1, 2 of them, so we get 2 redistillations. 1, 2, 3 distillations in total. Maybe good for a fruit brandy, but what if I want to make a whiskey? I don't want bubble caps in the first place, so they need to get out. What if I want to make vodka? I need 20 plates, so I need a much larger column. Larger building, it's around 40 centimeters per plate. So you have to imagine that if you want to make vodka, you probably need a hole that is 10 or 11 meters tall. And you're going to pay for all that copper, right? Looks nice, no question about it, but it's not very functional, not very versatile. Every plate offers you 1 distillation. My new theory on distillation allowed me to design something different. What we do, we take off product, the robot closes or opens the outlet, and depending on the reflux settings, a certain amount of the product is redistilled, for instance for a vodka. Now if we just push product back, it would either redistill on the plates I just showed you, or it would fall back into the boiler. That blast isn't very good, doesn't really help us, right? We need to distill again. Plates, I told you I don't like them, they're very inefficient, very expensive. So what I designed is a special column packing that you just fill your column with. All the way down there. And the fun thing is that those column packing springs, which we call helicone column packing, are basically open. So the gas is traveling up from the boiler. Just go through them until they get cooled down and liquid for reflux, for instance for vodka making, is sent down. The reflux or liquid sent down create a water bath or a liquid bath in your column. You can now imagine that for the gases rising up, depending on the size of your liquid bath, it's easier or less easy to come through. Bigger column, bigger liquid bath means that you get more redistillations and a more pure product. Do we make a very small liquid bath? We just get 2 or 3 distillations for maybe a fruit brandy or an Irish whiskey or a lighter rum. We don't create a liquid bath at all because we open the robot, everything is taken out, all of a sudden we've got a pot still. Do we manage the robot? We can get up to 40 distillations. So now, instead of having a column that can give you 1, 2, 3 or maybe up to 20 distillations, with a lot of plates that you need to put in place or take out, or a lot of columns that you need to put next to each other, great business model by the way, we just offer you 1 column. It's probably a little bit over 1 meter tall depending on the size of the unit that you actually purchase, and within this 1 meter to maybe 1.50 meters, we can give you anything from 1 distillation until 40 redistillations. And the only thing you have to do is dial in on the computer what purity levels you want. The iStill will do it for you. All right, a wrap up. We talked a little bit about quality, and just a little bit. I showed you the solenoids, almost 3 kilos. The guy doing the filming actually tells me I should talk about the fact that our boiler walls are 4 and 5 millimeters thick instead of the normal 1.5, 2 millimeters, but no, we can go on and on. We talked about quality. We talked about batch production and how it helps us to maintain a high quality level at a very low cost price level. We looked into 3 of the innovations, and I can tell you we've got 20 more patents out there. But what does it mean to you? I'll tell you. I'll give you an example of somebody who phoned me from the UK and said, hey, I've got one of those old stills. A very well-known brand from southern Germany. I love it, it's big, but I've got an issue out, and that's why I call you. The reason I call you is because I make 220 bottles of vodka in 1 run. And that's on a 2,000 liter German still with a traditional setup, copper, bubble caps, 20 plates, 11, 12 meters high, costing him almost €500,000, $600,000. 220 bottles, 2,000 liters still. The running costs, just to fire the still up, just to do the run, were €650, around $700, $750 that is. So per bottle, around €3 just went into heating up the system in doing the run. Electricity, gas, not even the cooling water. He called me because he found this was a lot of money and he wanted to actually not just sell vodka, but gain a little bit of money doing it. So we set up an iStill 2000 next gen. Doesn't cost hundreds of thousands, first of all, just cost him €65,000. But more importantly, due to the innovations I talked about previously in this video, the efficiency of his run, not to say the quality of his product, but the efficiency of his run became much better. Do you want to know what it costs him to do a production run on a 2,000 liter iStill Next Gen, making 220 bottles of vodka? I can't really tell you, because when we did the test, we didn't make 220 bottles of vodka, but 250. We could push heads and tails further away, creating more product for him. Do you know what it costs in terms of electricity? This was an electric iStill 2000 Next Generation. To get him there, I'll write it down for you. 48 euros. Thanks for watching this video on quality, on production philosophy, on how innovations can help you out, become a better, maybe more affordable, actually making a profit kind of craft distiller. This is the first video in a series. This one was about some of the technologies and stuff. The next one will be about mashing in the ice still. Then there'll be a third one, fermenting in the ice still. And we'll do 2 more videos of making taste rich and of making pure vodka kind of product on the ice still. But that's for a few weeks from now. Thanks for watching.